Hi everybody. The goal of this problem set was to teach you a new way of thinking about trig functions when you see them in equations. I think a lot of students are used to learning a technique where I show you what to do. That is not the goal of this problem set. When you see tan x equals -1 or cosine x equals cosine opposite x, these equations are like English sentences that are telling you a very specific idea about things on the unit circle. So I want you to get used to asking yourself, what does this mean? And that was the goal of this problem set. So let's take a look at some examples. I guess we could start with these. So tan x equals -1. You could think, okay, so what is tangent x actually referring to? It's sine x over cosine x. And actually, I'm going to rewrite this with thetas here. So that way we can save x for an x coordinate. So what does it mean if sine x divided by cosine, if sine theta over cosine theta is -1? Remember what sine and cosine tell you. Sine tells you a y coordinate, cosine tells you an x coordinate. So this is like saying a y coordinate over an x coordinate equals -1, which is like saying a y coordinate is the opposite of an x coordinate. So the question is, what theta will make that happen? Where on the unit circle do we have a y coordinate that's the same but an opposite of an x coordinate? And it seems like that has to happen here or here, where this is an angle of 45 degrees. Because you know that the coordinates over here are -√2 over 2. It's a negative x coordinate. And then the y coordinate would be √2 over 2. So it's the same values, just opposite sign as it needs to be. Same story over here. Here the x coordinate is positive √2 over 2. The y coordinate is negative √2 over 2. So that's one way of thinking about it. And let's just review what the thinking process was. The thinking process was rewrite this in terms of sines and cosines, and then think about sine and cosine as an x coordinate and y coordinate on the unit circle. So that's how you can think about what is it really telling you. It's telling you some facts about x, y coordinates on the unit circle. And then you have to figure out what angle would make that true. A totally different way of thinking about it. Remember, sine over cosine also tells you the slope of the line that you get when you connect the origin to the point on the unit circle. So you could also think about this as asking, where is the slope of that line -1? Well, here is this entire line right here is the line y equals -x, which has a slope of -1. And so again, I see those 2 points both create these lines whose slope is -1. So you could think about it as slope. You could think about it as x and y coordinates. Okay, let's practice that same kind of thinking here. So what could this equation be telling us? Let's think about each part of this and then draw a little diagram to help. Okay, sorry, I turned the x's back into thetas. So cosine is telling me an x coordinate. So I could read this as saying the x coordinate of some angle theta is the same as the x coordinate at an angle -theta. Well, okay, how can I understand that? Let's just sketch a little picture. So if I've got an angle theta here, the x coordinate would be, in the new pen color, the x coordinate would be this bold green distance right there. Okay, where's an angle of -theta? Well, it's the same angle, just in the opposite direction here. Whoa. So let's pretend that my circle actually is good. And you can see that if we have the same angle in the opposite direction, these 2 points should be symmetric. And so they're going to have the same x coordinate. And that's all it says here, saying the x coordinate at an angle is the same as the x coordinate at the opposite of the angle. So you can verify that this makes sense just by thinking about what it's telling you and looking at the picture that you draw on a paper or in your mind. The other way you could think about this, you can also think about this using the tools that we had from before, which is transformations. So without actually labeling my axes here, if this is the graph of y equals cosine theta, what's the graph of cosine opposite theta? Remember that if you add a negative sign on the inside of a function, that corresponds to a horizontal reflection. So that's what would happen if I reflected this around the y-axis there. And you can see that if I reflect this around the y-axis, I just get the same graph. And that's all this is saying. This is saying my entire cosine function is the same if I reflect it horizontally. So the important thing is not this fact. I mean, this fact will become important much, much later in a different unit. What's important right now is the thinking process. If I showed you a completely new equation, could you say whether or not it makes sense by thinking in those two ways? Let's do one more. So without a calculator, which is larger, the secant of 10 degrees or the cosecant of 10 degrees? Okay, I want to be clear, this is not an important question to be able to answer. Like, obviously, if you wanted to know the actual values, you would just plug them into a calculator. So the goal is not answering this question. The goal is practicing this type of thinking, because the type of thinking is going to be useful for you. Okay, so what is that type of thinking? Remember, let's rewrite things in terms of sines and cosines, so that way we can use our natural intuition about them. We can use our common sense. So secant is 1 over cosine. So secant 10 degrees, I'll rewrite as 1 over cosine 10 degrees. Cosecant 10 degrees, I'll rewrite as 1 over sine 10 degrees. But now I can start thinking about them. So I want to know which one is bigger. So let's start thinking intuitively. If this is 10 degrees, this would be the sine of 10 degrees, that little tiny height. This kind of larger horizontal distance would be cosine 10 degrees. Okay, so how does that help me? I don't need to know the specific numbers. I'm just noticing that this is kind of a small distance and this is kind of a big distance. So you can think about this informally as 1 over something larger. And the question is, how does that compare to 1 over something that's smaller? Well, let's see. If I have 1 divided by something very, very small, that makes something big. So for example, if I had like 1 over 1/10. 1/10 is pretty small. That would create 10, which is pretty big. Let's compare that to if I had something larger. So like, what's larger than 1/10? Let's do like 9/10. That's like pretty big. So if I had 1 divided by 9/10, that would create 10 over 9, which is clearly much, much smaller than 10. So that's the idea. You can think intuitively. If you're dividing by a larger number, your overall value must be smaller. If you're dividing by a smaller number, your overall value must be larger. And so we can just think, okay, is cosine or sine of 10 degrees larger? It seems like cosine is larger, and so this one is going to end up being smaller. And our original question was which is larger, so it must be that cosecant is larger. So one more time, the specific question, not important, but I want you to get used to applying your common sense reasoning to a scenario by connecting it to the meaning of concepts. What does cosecant actually mean? What does sine actually mean? And then once you ask what does it actually mean, you can answer the question with common sense. Okay, hope that this was helpful.